Architectural design responds to multi-phase problems, and there are many considerations that should be taken into account. Function, time, lighting, environment, and many others. The main role player in architectural design is, however, its users. It is important to understand and explore how people behave and its ramifications in the built environment. However, until recent developments, it couldn't have been more than a prediction. With the enhancement in technology, many problems that are too complex for human being has become computable. Recent technological developments have also affected architecture. Various theories in other disciplines have been adopted in the context of architecture. This new way of thinking and working bring a completely new way of designing, thanks to potentials offered by computational tools. Agent-based theory rooted back to biology with the theory of bionics and mathematics with the theory of evolutionary algorithms. The agent model is a global system that is defined through agents. Agents are components that act autonomously in a complex environment. Agent-based modeling is used in several disciplines, like economy, software engineering, transportation, and robotics. This theory is important to predict and monitor behaviors. ABM, with its bottom-up and behavior-based approach, has huge potential in architecture. Krause says that agent-based modeling tries to uncover new definitions to architectural problems. In architecture literature, ABM is used with two different approaches. Since it is used in a design process, it gains a different meaning, and it will be called as agent-based design. In the simulative approach, users of space are seen as agents. With the agent-based design, the behavior of people is converted to the act of agents with some level of abstraction. After that, a simulation is created in a virtual design environment in order to monitor behaviors and make improvements in design. In the formal approach, the smallest design units are seen as agents. The designer defines agents and creates relationships between them. The design units act according to the defined rules and the defined relationships with other agents and the environment. In this way, the designer aims to achieve the fittest design scheme using design units. In the simulative approach of agent-based design, although the behavior of users in the built environment can be monitored and used to get information about design, this method is not used in a way that the data of simulation results are used directly to develop the design. In the formal approach, although the aim is to create an architectural design, the agents or the rules that define the acts of agents are not related to the behavior of users. Hence, although both approaches have huge potentials, they cannot be used to integrate the behavior-related information directly into the design process. However, the third agent-based design approach to architecture can be proposed. The new approach is defined as a result of the study on simulative and formal approaches, together with parametric works. With this study, it is aimed to provide a behavior-related methodology for the conceptual design phase of architectural or urban design projects. The methodology works in a way that the simulation data from the initial studies and analysis in the beginning of the design project is used for the creation of the initial concept. This methodology can be used to develop a conceptual design in an architectural design project based on the behavior of people. In this new iterative approach, the agents and the rules in the formal approach will be defined according to the agent's behavior in simulative approach. Gathered data from user simulations are used to develop the agents and the rules through parametric studies. Since formal approach and simulative approach are used in an iterative way, this approach can be named as iterative agent-based design approach. The iterative agent-based design approach is applied on the imaginary design project. The project is a funfair park. There is a main road on the north of the site, the small road on the west, and neighborhood in the south. The east of the project is designed as parking lot. According to created brief, there will be 6 activity groups and each of them is 20 meter wide and 20 meter long. In this study, 2 behavior-related design problems are issued and specific configurations for each of them are created with iterative agent-based design approach. The behavior-related design objectives are creating more equalized distribution of users and increase the quality of experience. It is hypothesized that placing activity spaces to areas that are not on the main user path will create more equalized distribution of users. In order to place activity spaces, user movement simulation is done. The simulation is carried out with 2000 agents and during 30 minutes. The half of the agents come to the array with a car. The other half come with other ways. Between the agents, they do not come with a car. The main entrance from the main road. It is aimed in this process to find spaces not on the main paths. In order to do this, the result map from simulation is embedded in the parametric design process. Color codes in the agent path map are unfolded and they are turned to point clouds. Finally, empty areas are extracted from the map. Spaces gained from point cloud are used to place activity spaces. In order to create the data to test empty space configuration, on-path configuration is created using the same method. In order to test the result, 5 different random configurations of the activity spaces are created. On empty spaces, on-path, and random configurations are put in the simulation of user movement. In order to compare the results, the level of people density in different configurations are listed. In the most suitable configuration, a distribution with no empty spaces and decreasing density of crowd is expected. The on-empty spaces configuration shows the most suitable condition for equalized distribution, while on-path shows the worst and random configurations in between. It is hypothesized that ease to access the activity spaces will increase the number of users. In order to manipulate place of activity spaces, one random configuration is selected and simulation is done with 500 agents and during 30 minutes. From the simulation, the density of each activity space is gathered. In order to understand the main factor that affect the number of experience, several variables are tested. Values from average distance to entrances, weighted average distance to entrances, average distance to other activities for each activity space are obtained. It is expected that when the average distances decrease, the number of users will be increased. Hence, there is an inverse proportion between user numbers and all average distances. In order to understand the main factor, the relation between the number of agents and average distances is investigated. In the optimum scenario, the main factor should have a constant value of number of users times average distance value. The most constant value in this design objective is the number of users times average distance to other activities. Hence, the main factor is the average distance to other activity spaces. In order to increase the number of users in each activity, distances between activity spaces are manipulated using the Maes center and value of number of users. At the end of parametric studies, new configuration is created. As a result of simulation, it is seen that there is an increase in average number of people. Iterative agent-based approach is able to be used for different behavior-based design objectives. With the emergence of this method, manipulation, optimization, and monitoring of human behavior in architectural design would be done efficiently. This study in this video is made as a part of Research by Design project that is aimed to explore how behavior-related information can be integrated to architectural design process.